Hello, welcome to another episode of Math with Haas. We are watching our series on Precalculus, Season 1, Episode 3. We are investigating exponentials and logarithmic functions. Now, last time we looked at an example of deer population and we introduced the notion of compound interest. Now, we're going to conduct a interesting experiment here. Suppose we invest $1 at 100% interest for 1 year. The question is simply this: how much money will you have? Now, you may be wondering, well, what is the compound? How many times is this compounded? What does n equal? That is going to be the interesting question. What does n do to the amount we make? So, we can see right away for a car equation, y equals, well, we weren't using y, we're using an a, so let's get our a back. A is equal to a times 1 plus r over n to the nt. So a here is going to equal 1. Since our interest rate is r, that's 100%. Well, 100% is also equal to 1. T is also equal to 1. So this is going to be a rather simple equation. So we got 1 plus 1 over n to the n. The t goes away because it's just 1. A is just 1. So this is really simplified. Okay. So we could think of how much money we have as a function of the number of times interest is compounded. Okay. So let's figure out some values here. So here's a, here's n. So suppose interest is compounded annually. Annually is when n is equal to 1. Let's figure this out. 1 plus, so we would have 1 plus 1 divided by 1, right? 1 plus 1 over 1, which is 2. Then we have 2 to the first. That's just 2. So you make a whole dollar. $2. Okay. What if we compound interest semi-annually? Okay, so we have 1 plus 1/2. And this is now going to be squared. Okay. So 3/2 squared, huh? Right, 1 plus 1/2, that's 3/2. 3/2 squared, that is 9/4. Okay, 9/4. 2.25. Hey, we've made an extra quarter. Let's see how much more we can make. Ooh, yeah. Quarterly. That is 1 plus 1/4 to the 4th. Okay. So 5/4 to the 4th. And let's just figure that out. 1.25 to the 4th. Okay. So that is a 2.44. Alright, so we're still making money. Damn it, let's go crazy. Let's do 12. What does that do? So 1 plus 1 over 12 to the 12. We'll just use a calculator now. Alright, we are still increasing. We have 2.61. We'll just go out another one. And decimal place others. Now, we can look at this. We have from n equaling 1 to 2, we have a gain of 25 cents. But now, from 2 to 4, it's not quite as much. Just 19 cents. And it's still good, but it's still 6 cents less. From 4 to 12, however, we have 17 cents. Maybe it is changing. We're increasing well, it is changing. The amount we're making is slowly less and less. But how much would we make if we did, say, if we compound interest daily, 365? So if we did 365, then we can calculate that out. Let's see here. So 1 plus 1 divided by 365 is to the 365. How much money are we going to make? What? 10 cents more? You gotta be kidding me. Compound interest every day and you only gain 10 more cents. Okay. Oh, I should round that up. Bad math. Better math. There we go. Now this was an interesting question. When we jump from 12 to 365, which is a significant jump, we're going to gain 10 cents. What happens if we say we compound interest 1,000 times? So let's go super crazy. Let's see here. 1 plus 1 divided by 1,000 to the 1,000. What? We didn't even gain a penny. Now that's strange. So, as n gets bigger and bigger, it seems like our values here for a approaches a maximum amount beyond which it can't return. If you don't believe me, we can plug this into our calculator here. So, if we treat our n's as x's, our equation was 1 plus 1 over n to the n, right? I'm just using x's here. And we can force the calculator to calculate everything for us. So I hit second in table, and look at this. There's when n is 1, 2. I didn't have to do all that work by hand. I could just force the calculator to be my slave here. Look at that. All that work. Profit. Here's the money. So if we hit second and table set here, we can actually adjust where we want this table to start. So let's see what does 10,000 look like. Boom, 10,000 right there. Calculated all the work. Okay, so 10,000. So an increase of 9,000 in n gave us 2.718. So we made just about 0.2 tenths. So we made 0.0012 amount of money by compounding it 10,000 times. Okay, that's not very much at all. So it does definitely seem like the increase is not that much as you increase in. Let's see here, let's go super crazy, see what a million does. So that is 100,000, there's a million right there. See, you can make a calculator do it just like that. 2.7182. Okay, so you make 0.0001 approximately, maybe 0.002. So the amount of increase in money is almost negligible. Going out to 1 million here, that's crazy. So it turns out that if we think about our function here now, think of this as an equation. Y equals 1 plus 1 over x to the x. Now, this, we can introduce some language from calculus without needing to do calculus, but it's useful information. We can say as x approaches infinity, we've noticed that as our number times n is compounded, as it gets bigger and bigger, this seems to be approaching a finite value. That is called a limit. Okay. So as x approaches infinity, y is going to approach a number, and we're going to give it a name. Y approaches the number e. You're like, what? What's e? So e is Euler's number, and it is approximately, let's find out. Second, get out of there. Second, if you notice there's a little e right here above the division. To access it, you hit second, and then we hit the division. There's e. Boop. 2.71828 dot dot dot. And if we notice, hey look, that's the first 4 digits right here. So the claim is, as x gets larger and larger to infinity, the amount of money you would make would approach Euler's number. And Euler's number is this nice decimal. So Euler's number is a transcendental number, like pi. Pi is has decimal places that go into infinity. So is Euler's number. It turns out that Euler's number is shows up all over the place, like you wouldn't believe. Just how pi is very useful, shows up all over the place, especially in terms of circles. Euler's number will appear quite often in math. It's quite remarkable. So here we are in exponential functions, and we've already discovered a new number. How exciting is that? A new number, which means more fun. So this brings us to another button on the calculator. If we hit second, we got this weird button that says ln, whatever that is. If you hit second and then this ln button, you have an e to an exponent built in. Every scientific calculator, graphing calculator has that built in. So if we want to see what e to the fifth was, there it is, about 148. I hope you've enjoyed this video. So what we've done here is discover a new number, Euler's number. When we continue, we will develop this further and do some more examples. If you've been enjoying our content, please subscribe. I enjoy having all of you watching the videos. Gives me a pleasure to teach you. If you also check us out on Patreon. Thank you for joining our math party, and see you next time.